Imagine looking at the night sky, you see the same familiar moon, glowing silver, watching over us as it has for billions of years. Humanity has told stories about it, studied it, even visited it. For most people, that single moon is enough, our only natural satellite. But what if I told you Earth sometimes has more than one? What if hidden among the stars, quietly orbiting in a strange cosmic dance, there exists another body tethered to Earth's gravity in ways that defy expectation? This is not science fiction, it is a scientific reality. In 2025, astronomers confirmed a small asteroid like object that appears to circle near our planet. Its name is 2025 PN7 and it is what scientists call a Quasi-Moon, a strange temporary companion of Earth that follows us through space, locked in a gravitational relationship that is as delicate as it is mysterious. For centuries, humans have wondered whatever Earth could have more than one moon. Legends spoke of hidden companions, invisible celestial neighbors, or a wandering stars. In modern times, astronomers occasionally discovered asteroids that behaved unusually. They did not simply orbit the Sun, nor did they orbit Earth in a traditional way. Instead, they moved in complex, looping paths bound by a gravitational tug of war between our planet and the Sun. These are Earth quasi-satellites, and now 2025 PN7 has joined the list. But what makes 2025 PN7 truly fascinating is not just its existence, it's what it represents. This object isn't merely a rock floating near Earth, it is a cosmic messenger, a reminder that the solar system is more dynamic than we think. The moon may be Earth's only permanent satellite, but we are never truly alone. Our planet occasionally gathers companions, keeps them for a time, and then lets them drift away. These companions tell us stories about the chaotic history of our solar system, about the delicate balance of gravitational forces, and perhaps even about the future of space exploration. In this documentary style journey, we will explore everything about 2025 PN7. We will uncover what quasi-moons are, how astronomers discovered them, why they matter to science, and what they reveal about Earth's hidden cosmic relationships. We will dive deep into orbital mechanism, myths of second moons, and the role of these small bodies in planetary defense. Even the existing possibilities they hold for future asteroid mining. Think of it as a voyage across time and space. From ancient sky watchers who imagined more than one moon to modern astronomers using telescopes and computers to confirm their existence. By the end, we will see that Earth's story is not limited to one bright satellite. Instead, our home has secret companions, and 2025 PN7 is just the newest chapter in that tale. But before we go deeper, let's set the scene. Imagine Earth not as a lone traveler through the solar system, but as a planet with shifting company. Imagine a hidden dance where small objects waved around us, coming and going in cycles that stretch across decades. Most of humanity never noticed them. Most textbooks don't even mention them. Yet, here are they, proof that our corner of space is more alive and more mysterious than we ever thought. And that is why 2025 PN7 has captured the imagination of astronomers and dreamers alike. It is a small, yes, it may only be a few dozens meters across, a cosmic pebble compared to the grandeur of our moon. But in its orbit lies a mystery of balance and motion. In its story lies the key to understanding how celestial bodies interact in subtle, surprising ways. Welcome to Famous Frontier, where today we unveil the tale of Earth's newest Quasi-Moon, from its discovery in 2025 to the science behind its strange orbit. We will uncover the mysteries of 2025 PN7, Earth's hidden companion. This is not just about rocks in space, it's about how the universe constantly reshapes our perspective. It's about how something so small can change the way we think about our own planet and its place in the cosmos. And it's about how we as humans are only just beginning to notice the many secrets that orbit around us. So buckle up, our journey begins now with a simple but profound question. The question is, what exactly is a quasi-moon and how does 2025 PN7 fit into Earth's cosmic story? When most people hear the word moon, their mind instantly turns to Earth's familiar companions, the large, bright object we see in the night sky. Our moon is permanent, massive compared to other satellites in the solar system, and plays an essential role in stabilizing Earth's climate and tides. But what if we told you that Earth sometimes has more than one moon? Even if only for a while. This is where the concept of a quasi-moon comes in. To understand this makes 2025 PN7 so fascinating, we first need to grasp the science and the strangeness behind this category of object. A quasi-moon is not a true moon like the one we have used to. Instead, it is an asteroid or a small celestial body that follows the Earth in its orbit around the Sun, staying close to us over long periods of time but without being permanently captured by Earth's gravity. In simple words, the Moon orbits Earth directly. A quasi-moon orbits the Sun, but it does so in a way that makes it seem like it is orbiting Earth. If you were to look at the path of a quasi-moon from a bird's eye view of the solar system, you would see something strange. The quasi-moon moves around in a horseshoe-shaped or kidney-shaped orbit, sometimes appearing to circle Earth, sometimes moving ahead, sometimes falling behind. It's like a cosmic dance partner, never fully locked into Earth's orbit but never wandering too far away either. Why does this happen? It comes down to a delicate gravitational balance. The sun's gravity is always the dominant force in the solar system. Everything, Earth, Mars, asteroids, comets, orbits the sun. But Earth's gravity is also influence objects that pass close enough. While certain asteroids happen to orbit the Sun at almost the same speed of Earth, they can get stuck in a kind of gravitational relationship where they follow Earth's path never straying too far. This relationship creates the illusion that the asteroid is orbiting Earth. In reality, both Earth and the asteroid are orbiting the Sun, but because their speeds and distance line up, the asteroid seems to lobe around our planet. That is the essence of a Quasi-Moon. One of the most important things to know about Quasi-Moon is that they are temporary. Unlike Earth's permanent moon, which has been with us for 4 billion years, Quasi-Moons drift in and out of Earth's company. Some may stay with Earth for decades, others for centuries, but eventually gravitational nudge for the Sun and other planets sends them on their way. In fact, astronomers often describe them as transient satellite or pseudomoons. They are cosmic hitchhikers, companions for a while but never truly permanent. 2025 PN7 is not Earth's first Quasi-Moon. Astronomers have discovered several others in recent decades. A Quasi-Moon named 2023 YN107. It is a small asteroid that became a Quasi-Moon on Earth between 1996 and 2026. Its orbit looked like a looping lasso around our planet before it eventually drifted away. Another Quasi-Moon name is 2026 H03. Sometimes called Earth's constant companions, this asteroid has been a stable Quasi-Moon orbit for almost a century and is expected to remain there for centuries more. NASA even nicknamed it Earth's second moon. Another Quasi-Moon named 2020 CD3, discovered in February 2020. This mini-moon was only a few meters wide. Unlike most Quasi-Moon, it was briefly captured by Earth's gravity and orbited us like a true moon for about 3 years before drifting off. And another Quasi-Moon named 2026 H03, a particularly fascinating Quasi-Moon that also appears to be a fragment of a much larger asteroid. Its name comes from Hawaiian meaning a oscillating celestial object. This discovery shows that Earth is not alone in this phenomenon. Quasi-moons are rare, but they are part of the larger family of objects called near-Earth asteroids. Quasi-moon like 2025 PN7 are more than just curiosities. They are valuable to astronomers for several reasons. Number 1. Windows into orbital dynamics. Studying their strange paths helps scientists understand how gravity works in three-body system, and this three-body is Earth, Sun and asteroid. It's like a natural experiment in orbital mechanism. Number 2. Accessible space targets. Because Quasi-moons move close to Earth, they are easier to spacecraft to reach compared to asteroids in the main belt. This makes them prime candidates for missions, mining, or even planetary defense testing. Number 3. Potential clues to Earth's history. Some Quasi-moons might be fragments for larger collision in the past. By studying their compositions, we might learn about the violent history of Earth and its neighborhood. And the number 4. Planetary defense practice. Since these objects come near Earth, tracking their orbit sharpens our ability to detect potentially hazardous asteroids in the future. Let's clarify a bit more because the terminology can be confusing. True moon is orbits Earth directly like our moon. Quasi-Moon. It orbits the Sun but stays near Earth in a looping, synchronized orbit. Captured asteroid. It's an asteroid that gets caught by Earth's gravity for a short time and actually orbits Earth, like 2020 CD3. So, while quasi-moons are often called second moons, they are not technically moons at all. They are more like shady partners moving alongside us but always under the sun's control. In the grand scheme of the cosmos, quasi-moons remind us of how fragile balance can be. They exist in a constant tug of war. Earth pulls them one way and Sun pulls them another. And yet, somehow they manage to stay near us. Their orbits are mathematical works of art shaped by the invisible strings of gravity. And now, 2025 PN7 has joined this small but fascinating group. Discovered in the near 2025, it is Earth's newest companion, and its orbit places it in the spotlight of astronomical research. Now that we understand what a quasi-moon is, the next big question is, how did astronomers find 2025 PN7? What made it stand out among the countless rocks floating in the space? The story of 2025 PN7 begins not with a flash of light in the sky or the naked eye of a stranger, but with the quiet hum of telescopes, computers, and data analysis. Unlike the moon, which has dazzled humanity for millennia, quasi-moons like 2025 PN7 are subtle, dim, and often indistinguishable from the endless sea of stars. Their discovery represents one of the greatest achievements of modern astronomy, the ability to track tiny, fast-moving objects that silently share our orbit around the Sun. By the early 21st century, astronomers had entered a new era of discovery. Instead of relying solely on human observers, wide-field telescopes equipped with powerful digital cameras scanned the heavens each night. Automated software compared images taken minutes, hours, and days apart, searching for anything that moved. This method, known as a sky survey, became the backbone of asteroid discovery projects like PN7, Catalina Sky Survey, and Atlas, and also space-based missions like New Wise. Transformed astronomy into a game of cosmic detective work. These surveys weren't just for science curiosity, they were part of a global effort to track near Earth objects that could pose a collision threat. It was through this wave of technology and diligence that 2025 PN7 was discovered. In mid 2025, astronomers noticed a faint, slow moving point of light against the starry background. At first glance, it seemed like just another small asteroid, one of thousands discovered each year. It was given a provisional designation 2025 PN7 according to the International Astronomical Union's naming system. But what caught astronomers' attention was its orbit. As tracking data accumulated over several nights, then weeks, it became clear that this object wasn't just any asteroid. Instead of racing past Earth or circling the Sun in a distant path, its motion was strangely synchronized with Earth's own orbit. The object wasn't coming closer like a potentially hazardous asteroid, nor was it drifting away. Instead, it seemed to be keeping pace with our planet, hovering in a dedicated balance. Computer models soon confirmed the truth. 2025 PN7 was a Quasi-Moon. The process of confirming a quasi-moon isn't simple. Unlike true moons, which can be easily identified because they orbit Earth directly, quasi-moons require precise orbital analysis. And they are: number 1. Its net initial detection. Telescopes captured images of the object on multiple nights. Its position was locked and compared to known stars. Number 2. Orbit calculation. Using the data, astronomers calculated the object trajectory. This step is crucial. Even small measurements errors can change the prediction dramatically. Number 3. Long-term simulation. Computer models projected its orbit decades into the future. This simulation showed that 2025 PN7 wasn't a passing asteroid but a long-term companion to Earth, looping around us in a quasi-satellite orbit. Number 4. Peer review and verification. Other observatories confirmed the data, ensuring it wasn't false detection. Within weeks, the global astronomy community acknowledged 2025 PN7 as Earth's newest Quasi-Moon. Discovering something as small and faint as 2025 PN7 would have been impossible without cutting-edge technology. Consider the challenges. Quasi-moons are usually no more than a few dozen meters wide, far smaller than most asteroids. They reflect very little sunlight, making them dim against the night sky. They move just enough between images to be mistaken for background noise if not carefully tracked. Modern telescopes can detect objects as faint as 22nd magnitude or even dimmer. To put that in perspective, the faintest stars visible to the naked eye are around 6th magnitude, meaning quasi-moons are millions of times fainter than what the human eye can see. Software algorithms play an equally important role. They shift through terabytes of data, flagging potential moving objects for astronomers to verify. Without automation, the discovery of 2025 PN7 would have been like finding a needle in a galactic haystacks. When the discovery of 2025 PN7 was confirmed, it sparked excitement not only among scientists but also the general public. Headlines spared: Earth has a new quasi-moon, second moon discovered around Earth short of. Meet 2025 PN7, our planet's temporary cosmic companions. The idea of Earth having a second moon is irresistible to the human imagination. While astronomers were careful to clarify that quasi-moons are not the true satellites, the media and public embraced the discovery as evidence that Earth's story is more complex than we thought. For many, it was a reminder that space is not a static thing. New objects come and go, sometimes unnoticed, sometimes celebrated. In a universe where most things seemed eternal, 2025 PN7 reminded us that even moons can be temporary. One of the most first questions scientists asked was, where did 2025 PN7 come from? There are several possibilities. It may have originated from the asteroid belt between Mars and Jupiter and been nudged into Earth's neighborhood by gravitational interactions. It could be part of a population of asteroids that frequently cross Earth's orbit, occasionally getting caught in Quasi-Moon's configurations. Some speculate it could be a fragment of a much larger collision, possibly even related to past impacts on Earth or the Moon. Determining its origin requires studying its compositions, which can only be done through advanced telescope or future spacecraft missions. The discovery of 2025 PN7 echoed earlier finds such as 2026 H03, another quasi-moon that became famous for its stability, but unlike 2026 H03, which will stay with Earth for centuries, 2025 PN7 may only remain the Earth's company for a few decades. This difference made astronomers even more eager to study it while it's here. Every quasi-moon discovered so far has expanded our understanding of orbital dynamics. Each one is a new case study, a new puzzle piece in the story of how Earth interacts with its cosmic environments. 2025 PN7 is no exception. The significance of 2025 PN7's discovery goes beyond the headlines. Humanity's ability to track objects only a few dozens meters wide across millions of kilometers of space is extraordinary. Quasi-moons are perfect targets for robotic missions. A spacecraft sent to 2025 PN7 could test asteroid sampling, mining, or even planetary defense techniques. Announcements like this inspire curiosity and wonder, encouraging people to learn more about astronomy and space exploration. Now that we know how 2025 PN7 was discovered, the next step is to explore its orbit and motion. How exactly does its tiny object manage the stay near Earth without being a true moon? The answer lies in the fascinating world of orbital mechanics, and that's where we will go next. If you have ever watched two dancers moving across a stage, sometimes close, sometimes apart, but always following the same rhythm, you already understand something about how Quasi-Moons works. 2025 PN7 doesn't orbit Earth the way our moon does. Instead, it performs a cosmic dance with which Earth is both partner and anchor. To truly appreciate the strangeness and beauty of this motion, we need to step into the world of orbital mechanics. But don't worry, we'll keep it simple, clear, and fascinating. Before diving into PN7's orbit, let's quickly revise what makes the moon's orbit so different. About moon, it's 384,000 km away, locked in a stable elliptical orbit, bound directly by Earth's gravity. It always circles us again and again, never drifting away. But about 2025 PN7, roughly 90 meters wide, but bound to Earth, but to the Sun. Its orbit is almost identical to Earth's, which makes it appear to follow us, looping around in patterns that seem ghost-like and temporary. This distinction is crucial. PN7 doesn't belong to Earth the way the moon does. Instead, it's like a traveler passing alongside us on the same path around the sun. The orbit of 2025 PN7 is what scientists call a quasi-satellite orbit. Here how to picture it. Imagine Earth and PN7 has two runners on a circular track around the sun. Earth is in the inner lane, PN7 is in almost the same lane but just slightly offset. As they run, PN7 sometimes seems ahead, sometimes behind, but always within sight. From Earth's perspective, PN7 looks like it's looping around us, but in reality, both are orbiting the Sun. The illusion comes from the synchronizing of their motion. This is why quasi-moons are sometimes called Earth false satellites. They look like moons, but they are not tied to Earth by gravity in the same permanent way. So how does PN7 manage this strange dance? This answer lies in a delicate balance between the Sun's gravity and the Earth's gravity. The combination of these two forces means PN7 never gets too far away, nor does it spiral down towards Earth. Instead, it stays in a looping path that can last for decades or even centuries before eventually drifting away. Think of it as Earth gravity giving PN7 a gentle nudge every so often, keeping it nearby without fully capturing it. Some quasi-moons follow what are called horseshoe orbit. From Earth's point of view, their paths look like giant horseshoe across the sky. At times, they approach Earth from behind, then they slow down, drift ahead, and eventually loop back. In the case of PN7, its orbit is more like a quasi-satellite loop, where it appears to circle which once a year in synchronous with our orbit around the Sun. Picture drawing overlapping spiral around Earth. That's how PN7 path might look if traced over times. It doesn't follow a perfect circle but creates a looping, flower petal like path. The moon, always around 384,000 km away on average. But 2025 PN7, its distance varied greatly. Sometimes it's relatively close and sometimes farther away. The key is that PN7's orbit keeps it near Earth's path around the Sun, so it seems like a long-term neighbor. But unlike the moon, PN7 is temporary. Models suggest it may remain as a quasi-moon for decades, possibly a century, before drifting away into a different orbit. Quasi-moons like PN7 live in a delicate zone between stability and chaos, too close to Earth, and they could be captured as a true temporary moon or crash into us too far, and they would break free of our gravitational influence, vanishing into space. What keeps PN7 nearby is its near perfect orbital resonance with Earth. Resonance means it takes almost exactly the same time as Earth to orbit the Sun, so their relationship stays locked in rhythm. Still, this stability won't last forever. Simulation predicts that PN7 will eventually drift away, possibly within a few hundred years. For now, though, it's our unusual companions. You might wonder, why all the fuss about an odd-shaped orbit? Here's why. Quasi-moons are natural laboratories for studying orbital mechanics. They show how gravity from multiple bodies can interact to create complex paths. By studying PN7's motion, scientists learn how small asteroids move, crucial knowledge if we ever need to detect one on a collision course. A quasi-moon's orbit makes it easier to reach than asteroids in the main belt. They are perfect for testing spacecraft navigation, mining, and even long-term bases. In short, PN7's orbit isn't just a curiosity, it's a roadmap for the future of space exploration. Let's bring it down to earth with a few analogies. Imagine jogging around a track. A friend jogs at almost your speed but slightly ahead or behind. To you, they seem to drift closer or farther, but really, you are both just circling the track together. That's PN7 and Earth. Think of Earth as a child holding a kite string and the sun as the wind. The kite doesn't circle the child directly but hovers nearby, held in a place by a balance of forces. PN7 hovers like that, not fully ours, not fully free. Imagine sitting on a Ferris wheel with someone in the next seat over. They rise and fall in sync with you, always nearby, but they are not tied to your seat. That's the illusion of PN7 orbiting Earth. So, what happens next? Will PN7 remain forever? The answer is no. Computer models show that for the next few decades, PN7 will continue looping near Earth. Small gravitational influences from other planets will eventually destabilize it. Sometimes in the future, it will drift away, becoming just another near Earth's asteroid. In other words, PN7 is only a temporary visitor. It's not here for billions of years like the moon, but for a cosmic moment, one we are lucky to witness. Understanding PN7's orbit gives engineers a roadmap for potential missions. A spacecraft could rendezvous with PN7 relatively easily since it shares Earth's orbit, practice anchoring mining and deflecting techniques, collect samples to learn about asteroid composition. NASA and other space agencies are already considering quasi-moons as stepping stones to the wider solar system. PN7 could be part of humanity training ground for deep space. Now that we understand the strange orbital dance of 2025 PN7, let's widen the scope. Is PN7 unique, or has Earth had other quasi-moons before? In the next chapter, we will compare PN7 with its predecessors and the forgotten companions that once orbited alongside us. When astronomers announced the discovery of 2025 PN7, it immediately joined an elite and fascinating family of objects, Earth's Quasi-Moon. Though they sound are rare and mysterious, Quasi-moons are not unique to PN7. In fact, Earth has had several of these ghostly companions over the decades. Each one has its own story, its own dance, and its own lessons to teach us. By comparing 2025 PN7 with other quasi-moons, we can better understand not only its place in the solar system but also what makes it special. Before diving into the lineup, let's remind ourselves of the definition. Quasi-moons are small, near-Earth asteroids that orbit the Sun in a way that keeps them close to Earth. From our perspective, they appear to loop around Earth in complex patterns like satellites. But unlike the Moon, they are not gravitationally bound to Earth. They belong to the Sun. Think of quasi-moons as Earth's fellow travelers, striking close to us as we orbit the Sun. They are companions but never truly ours. Over the years, astronomers have identified several quasi-moons, which brought new insight into orbital mechanics and Earth's near-space neighborhood. Let's meet them. 3753 Cruthin, the famous second moon. Discovery 1986. Its size about 5 kilometers in diameter and its orbit type is horseshoe orbit. Cruthin is often called Earth's second moon, though it's technically not a true satellite. Instead, it follows a horseshoe-shaped orbit relative to Earth. From our perspective, Cruthin appears to zigzag around Earth in a long, looping path, but in reality, it's orbiting the Sun, just like us. Comparison to PN7, Cruthin is massive compared to PN7. PN7 follow a quasi-satellite orbit, staying much closer, while Cruthin horseshoe orbit keeps it at the greater distance. Cruthin is a long-term companion, while PN7 may only stick around for decades or centuries. Cruthin taught us that Earth's orbital companions can be large and long-lasting. PN7 shows us that even teeny objects can share this relationship, if only temporarily. Number 2, 2002 AA29, a dancing asteroid. Discovery 2002, size about 60 meters in diameter. Orbital type horseshoe orbit with transitions. This small asteroid follows a horseshoe orbit similar to Cruthin's, but every 95 years it transitions into a quasi-satellite orbit, looping around Earth for a few decades before returning to its horseshoe path. And its comparison to PN7, similar in size and range. Both display quasi-satellite behavior, but PN7's orbit is more constantly in the quasi-satellite mode. 2002 AA29's regular transition make it less stable, while PN7 may remain near Earth for longer stretches. 2002 AA29 showed us how dynamic quasi-moons can be, constantly shifting between orbital states. PN7 reminds us that even in apparent stability, nothing is permanent. Two 2003 YN107, a brief visitor. Discovery 2003, size about 20 meters in diameter. Orbital type quasi-satellite. This asteroid is perhaps the most similar to PN7 in terms of size and orbit. YN107 became Earth's quasi-satellite in 1996 and stayed until 2006 before drifting away. And its comparison to PN7, nearly identical in size, both are small quasi-satellites with temporary lifespans. YN107 only stayed for about 10 years, while PN7 is expected to remain much longer. In many ways, PN7 can be seen as a spiritual successor to 2003 YN107, another small fleeting cosmic companions. 2016 H03, the constant companions, and its discovery is 2016. Its size is about 40 to 100 meters in diameter, and its orbit type is quasi-satellite. Nicknamed Earth's constant companions, 2016 H03 is considered the most stable quasi-moon currently known. It's expected to stay near Earth for centuries, orbiting in a tight quasi-satellite path. Its comparison to PN7 is much larger than PN7. H03 is more stable, guaranteed to remain Earth's companions for a long time. PN7 may not stick around as long, but its discovery highlights how many of these companions we might have at any given time. If H03 is Earth's loyal friend, PN7 is more like a guest, visiting for a while before moving on. Now what we have compared PN7 with its predecessors, what stands out about our newest Quasi-Moon? Discovered in 2025, PN7 reminds us that even now, with all our satellites and telescopes, space can be still surprise us. At just 19 meters, it's small enough to be a cosmic pebble, yet big enough to catch attention. Unlike many transient quasi-moons, PN7 is predicted to remain stable for decades, possibly a century, longer than 2003 YN107, though not as enduring as 2016 H03. Because PN7's orbit is so close to Earth, it could become a prime target for exploration missions, sample return, or even asteroid mining experiments. Each Quasi-Moon teaches us something. Cruthing showed us larger companions can exist. 2002 AA29 revealed the dynamic nature of orbital transitions. 2003 YN107 gave us a glimpse of fleeting companionships. 2016 H03 demonstrated long-term stability. 2015 PN7 proves that even small temporary companions deserve study, as they may hold keys to understanding orbital mechanics, asteroid behavior, and Earth's near-space environment. Together they form a cosmic family, Earth's unofficial moons. There is something deeply human about naming categories and comparing Earth's companions. We only have one true moon, yet we yearn for more. When quasi-moons like PN7 appear, they fuel our imagination. They are hidden protectors, stepping stones to the stars, or just cosmic heat-seeking Earths passing through. This fascination mirrors mythology, where multiple moons, stars, or twin companions often symbolized balance, mystery, or destiny. In a sense, quasi-moons are modern myths written in orbital mechanics instead of poetry. Now that we have compared 2025 PN7 with its fellow quasi-moons, we can see it's part of a wider pattern of companions, each with its own quirks. But the real question is, why does PN7 matter to us here and now? In the next chapter, we will explore the scientific significance of this discovery and why astronomers are so excited about it. At the first glance, 2025 PN7 might look insignificant, just a 19-meter rock drifting through the void. But in science, size doesn't always determine importance. Sometimes the smallest objects carry the biggest lesson. Quasi-Moon like PN7 are windows into the mysteries of orbital mechanics, planetary defense, space exploration, and even humanity's long-term survival. In this chapter, we will uncover why PN7 is not just a curious discovery but a scientific treasure. Quasi-moons are laboratories for testing the laws of celestial mechanics. PN7 spot shows us how Earth's gravity interacts with the Sun's pull to create a delicate balance. The asteroid orbits the Sun in nearly the same period as Earth. Studying this resonance helps refine our models of orbital stability. Quasimoons sit on the edge between stable and unstable. Observing how PN7 evolves over decades gives scientists insight into how a small notch from Earth, the Moon, or other planets can destabilize or preserve these orbits. In short, PN7 acts like a test practice, helping define the very equation that describe how planets, moon, and asteroids move. When people think about dangerous asteroids, they often picture kilometers-wide extinction events. But in reality, most potentially hazardous objects are small to medium size, like PN7. Studying PN7 offers critical insights. By closely observing PN7's orbit, astronomers sharpen their ability to predict asteroid paths. If humanity ever needs to change an asteroid's course, a quasi-moon like PN7 could serve as a safe, small-scale target for testing. Objects of PN7 size are big enough to cause significant local damage if they entered Earth's atmosphere. Learning more about their behavior improves our defense strategies. In a way, PN7 is like a cosmic sparring partner, a harmless object that helps us prepare for more dangerous encounters. Quasimoons are attractive exploration targets because they are. PN7 follows Earth almost perfectly, making it easier to reach than asteroid in the main belt. Its size makes missions simpler. A spacecraft doesn't need enormous engineers or fuel reserves to rendezvous. Since PN7 won't stay forever, their urgency studying it now gives us a once in a lifetime chance. Potential missions include collecting pieces of PN7 to study its composition, testing how spacecraft can attach to small, low-gravity objects. Quasimoons could serve as practice sites for resource extraction before we move on to larger asteroids. For space agencies, PN7 is like a low-cost training ground on our cosmic doorsteps. Asteroids are time capsules. Unlike Earth, they haven't gone through billions of years of volcanic activity, erosion, or plate tectonics. Their chemistry often preserves conditions from the early solar system. If PN7 is a typical near-Earth asteroid, studying it could reveal possibly carbon-rich compounds or metal that date back to the solar systems of birth. Whatever it came from the asteroid belt, a collision or another source. How small bodies are transported across the solar system by gravitational nodes and resonances. Every asteroid tells a chapter of our solar system origin story. PN7 is the newest page in that book. We have mapped thousands of asteroids, but quasi-moons are still relatively rare discoveries. Each new one helps fill a knowledge gap. With PN7, scientists can test whether small quasi-moons are more common than previously thought. Compare its orbit and lifespan with earlier quasi-moons like 2003 YN107 or 2016 H03. Develop better detection techniques for faint, fast-moving objects near Earth. In other words, PN7 strengthens the scientific records, making it easier to spot and understand future companions. The discovery of PN7 will likely spark cooperation between global space agencies. NASA, ESA, JAXA, ISRO, CNSA all could play a role in studying it. The various agencies telescope around the world will track its orbit and share their data. Quasi-moons are accessible enough to become targets for multinational sample return or robotic exploration projects. Like the International Space Station, PN7 could inspire a joint scientific effort, reminding us that space exploration is bigger than any single nation. PN7 also matters as a proving ground for human technology and creativity. Imagine a spacecraft could practice autonomous render just with PN7. Even a small asteroid may contain useful metals like nickel, cobalt, or platinum. Engineers could practice nudging an asteroid with solar cells, ion engines, and kinetic impactors. In essence, PN7 is a classroom in space, teaching us lessons we will need if humanity hopes to extend beyond Earth. Science isn't just about data, it's about wonder. When the public hears about Earth's second moon, excitement follows. PN7 sparks curiosity in young people imagining careers in space science. Creatives weaving PN7 into stories or metaphors. Every day, people realize the cosmos is more dynamic than they thought. In this sense, PN7 isn't just a rock, it's a spark, igniting curiosity, inspiring discovery, and reminding us of our small but meaningful place in this universe. There's also a deeper perspective. Quasi-moons like PN7 remind us in impermanence. Our true moon is ancient, unchanging in human terms. Quasi-moons are fleeting, passing through like travelers. PN7 teaches us that not all companions last forever. Just as civilizations rise and falls, so too do Earth's temporary moons. In this way, it's a cosmic symbol of change, a reminder to cherish what we have while it's here. To summarize, here's why PN7 matters. It's a refined science, it prepares us for dangers, it invites exploration, it preserves history, it fills gaps, it inspires cooperation, it challenges technology, it exists imagination, and it symbolizes impermanence. Now that we have explored why PN7 matters to science, let's step into the realm of speculations. What risks and opportunity does its little world pose? Could it be mined? Could it hit us? Or could it serve as humanity's first step into a new age of exploration? In the next chapter, we will weigh the dangers and possibilities of Earth's newest companions. Whenever humanity discovers a new celestial body near Earth, two immediate questions arise. Is it a threat? And can it be useful? With 2025 PN7, both questions are alive and urgent. On the one hand, its teeny Quasi-Moon reminds us of the constant risk of asteroid impacts. On the other, it opens up possibilities for mining, exploration, and space defense that could shape humanity's future. Let's dive into both sides of this cosmic coin, the dangers and the opportunities of Earth's newest companions. 2025 PN7 is small, just 19 meters across, but even a small asteroid can pack a terrifying punch. If PN7 even entered Earth's atmosphere intact, the energy released could rival the force of thousands of tons of TNT. Most asteroids of this size explode in the sky rather than hitting the surface, but as the Chelyabinsk event of 2013 showed, even an airburst can injure thousands and damage cities. Orbits shifts over time due to gravitational nudge, solar radiation, or collision, though PN7 is safe for now. Predicting centuries into the future is never absolute. In short, PN7 is not a domestic rock, but it's a reminder that Earth swims in a cosmic shooting gallery. PN7 provides a natural test case for planetary defense. Observing PN7 helps refine algorithms that predict asteroid paths with higher accuracy. Scientists could one day test launching PN7 with kinetic impactors or solar cells, practicing on a harmless target before facing a real threat. PN7 demonstrates how a small object can evade detection until they are close. Studying it sharpens the global network of telescopes. Instead of being feared, PN7 can be embraced as a training partner of defending Earth. Beneath its rocky surface, PN7 may hide valuable materials. Many near-Earth asteroids contain iron, nickel, and cobalt. This could be used for building a space station. Rare elements on Earth, potentially abundant in space, could revolutionize technology. Some asteroids carry water locked in minerals, a key resource for drinking life support or splitting into hydrogen fuel. PN7 is too small to sustain large-scale mining, but it could serve as a prototype site, a testbed for developing technology that will one day extract resources from larger bodies. Imagine PN7 not as a threat but as a way station. Missions could test anchoring systems and navigation techniques. If PN7 contains water, it could one day be harvested to refuel spacecraft en route to Mars or beyond. Because it's small and close, PN7 is a safer, fast step for astronauts before taking bigger, riskier missions. In this sense, PN7 could be humanity's first stepping stone into the solar system. Beyond survival in mining, PN7 could unlock fundamental knowledge. By studying its minerals, we glimpse the building blocks of planets. Small craters and surface scars may reveal how objects are battered by cosmic debris. By studying PN7 alongside its cousins, we learned how temporary moons form and fade. Every rock in space is a library, and PN7 may contain volumes of untold stories about our cosmic past. Ignoring PN7 comes with its own dangers. If we don't study objects like PN7, we remain vulnerable to larger undiscovered cousins. Resources left untapped mean progress in space exploration slow down. If only one nation explores or mines PN7, it could spark conflicts over space ownership. In other words, the biggest risk might not be PN7 itself, but humanity's failure to learn from it. Rather than competing, the world could unite around PN7. Multiple space agencies could share cost and expertise. Observations of PN7 could be distributed globally to inspire young scientists. Just as Apollo united the world in wonder, a mission to PN7 could symbolize peaceful exploration. In a fractured world, even a teeny rock in space could become a bridge. Opportunities brings responsibility. With PN7, tough question emerge. Should humanity mine small bodies or preserve them for science? Who owns PN7? No nations, yet laws about asteroid mining are still being debated. Could altering its orbit for mining or defense accidentally increase risks? PN7 forces us to consider not just what we can do, but what we should do. Finally, PN7 is more than a rock, it's a metaphor, a reminder that dangers and opportunities often come hand in hand. Quasi-moons don't last forever. They are cosmic travelers just like us. The spirit of exploration that drove us to the moon and Mars now calls us to PN7. When we look at PN7, we see not just a stone but a mirror reflecting humanity's fear, hopes, and relentless drive to explore. Now that we have weighted the risks and opportunities, let's step into humanity imagination. How does PN7 fit into the larger story of humans and the cosmos? In the next chapter, we will explore PN7 as a symbol of our collective future, blending science, philosophy, and vision into one cosmic narrative. (2025) PN7 may be small, a mere 19-meter traveler through the void, but its discovery invites us to ask larger questions. Beyond science and engineering lies a deeper realm. What does this mean for humanity destiny? This chapter explores PN7 not just as an object, but as a symbol of our relationship with the cosmos. It invites philosophy, spirituality, and vision to meet science and technology. For most of human history, the night sky was a mystery. Stars were gods, comets were omens, and the moon was unreachable. Now, with PN7, we see our temporary companions orbiting alongside us. It whispers, "You are not alone." PN7 reminds us that Earth is not isolated. We are part of a cosmic dance. Its teeny size compared to Earth highlights the fragility of both planet and species. By studying PN7, we weave ourselves into the larger fabric of the universe. These presences of PN7 encourage humanity and oh, unlike Earth's moon, PN7 won't stay with us forever. Quasi-moons are temporary visitors pulled by gravity threats until they slip away. The impermanence of a lessons, civilizations rise and falls, species appear and vanish, and even cosmic companions drift away. Just as PN7 won't always orbit us, opportunities in life and history must be seized when they appear. The fleeting nature of PN7 mirrors the fleeting nature of human existence, fragile but meaningful. Philosophically, PN7 teaches us the value of now. In many ways, PN7 is small but significant. Humanity is teeny in a cosmic scale, yet capable of profound impact. Just as PN7's orbit will one day end, humanity's time on Earth may be temporary. Like a Quasi-Moon, humanity drifts, exploring, searching, never fully still. PN7 becomes a mirror in which we glimpse our own cosmic identity. What will future generations say about us when they look back at the page of PN7's discovery? If we ignore it, they may call us blind to opportunity. If we study it, they may thank us for opening a new era of planetary defense. If we use it, they may see PN7 as the first step toward humanity becoming a spacefaring civilization. Legacy matters. PN7 forces us to think not in years or centuries, but in millennia. PN7 is not just an object, it's a stepping stone. Imagine mining PN7's materials to build the first orbital infrastructure, using PN7 as a training ground for asteroid redirection missions, anchoring research outpost on PN7 where astronauts prepare for Mars and beyond. The vision is clear. PN7 could be remembered as the rock that turned humanity outward. Across cultures, celestial objects inspire myths. What myths might PN7 spark? Perhaps PN7 will become the wanderer moon, a symbol of impermanence. For some, PN7 could represent guidance, a light that briefly joins Earth's path. Poets, musicians, and painters may turn PN7 into a muse, much like the moon inspired ancient cultures. Science may describe PN7, but art and spirit give it meaning. In a divided world, PN7 invites unity. PN7 orbits Earth, but no nation owns it. This makes it a shared treasure. Defending Earth, mining space, or studying the cosmos are challenges beyond borders. Children looking up at PN7 may dream not of war, but of exploration. In this way, PN7 becomes not just a rock, but a symbol of collective destiny. Eventually, PN7 will drift away, but the lessons it leaves may endure. Better telescope, stronger space defense, and improved mining system. A reminder of impermanence, humanity, and interconnectedness. The spark that launches humanity into the wider cosmos. We may lose PN7, but we gain perspective. Finally, PN7 reminds us that the universe is full of wanderers, comets, asteroids, planets, and even stars all move in cycles of appearance and disappearance. Earth has one permanent moon. It now has a temporary companions, and one day it may send forth ships that become the quasi-moons of distant stars. We are not spectators of the cosmic tapestry. We are thread within it. We have journeyed through PN7 discovery, orbit, risks, opportunities, and mining. Now it's time to conclude our odyssey. In the next chapter, we will weave together all threads, science, philosophy, and vision into a powerful finale that leaves our audience inspired to look up, wonder, and believe in the frontier of the future. Every story must end, but endings are also beginnings. The table of 2025 PN7, a teeny, temporary quasi-moon of Earth, is not just about a rock, it's about us, our fears, our hopes, and our unshakable desire to reach beyond. As we conclude this journey, let us step back and see the grand picture. What PN7 teaches us about who we are and why we are going. At first glance, PN7 seems insignificant. 19 meters wide, invisible to the naked eye, here today, gone tomorrow. But behind that modest frame lies a revelation. Even the smallest objects matter in the vastness of space. Their orbits are lessons in celestial mechanics. Their presence sparks human imagination and ambition. What begins as a rock becomes a symbol of vigilance, curiosity, and potential. PN7 also reminds us of danger. The universe does not care for human schedules or civilization. One asteroid, unnoticed, could change everything. But awareness breeds resilience. By studying PN7, we sharpen our tools of planetary defense, ensuring Earth is not just lucky but prepared. Our fragility becomes the seed of our strength. Risk aside PN7 is also an invitation. It whispers of opportunity, resource for mining and exploration, a training ground for future missions, a prototype for living and working in space. In 2025 PN7, humanity sees not just survival but expansion, the first spark of a truly spacefaring species. Beyond utility, PN7 carries philosophy. It teaches impermanence. Nothing lasts forever, not even celestial companions. It reflects our own journey, small, ordinary, but meaningful. It inspires wonder, proof that even in a chaotic universe, beauty and connection exist. Science may measure PN7, but meaning comes from what we see in it. The discovery of PN7 fits into a much larger story. Once, human thought Earth was the center of everything. Then we learned we orbit the sun. Then we learned the sun is one star among billions. And now we see that even small companions wander near us. Step by step, our place in the universe grows clearer. We are not central, but we are participants, active weavers of the cosmic fabrics. Every generation has a frontier. For our ancestors, it was oceans and continents. For us, it is the cosmos. PN7 are messengers calling, come further, learn more, take the next step. Whether through robotic missions, human voyages, or simply watching the skies, PN7 challenges us to expand our boundaries. No nation owns PN7. No single culture claims it. It belongs to all the earth. In this way, it symbolizes unity. When humanity looks outward, our divisions shrink. We remember that we share our fragile planet, orbiting one star, visited by one teeny Quasi-Moon. Exploring PN7 is not just science, it is a collaboration. prove that the stars belongs to everyone. Ultimately, PN7 points towards humanity's destiny. We are not meant to remain on one world forever. We are wanderers, builders, dreamers. Just as PN7 drift between orbits, so too will humanity drift between stars. This is not just about survival, it's about becoming what we are meant to be, a cosmic civilization. As we close these narratives, let us remember PN7 is small, but its meaning is vast. It's a reminder of risks, a beacon of opportunity, and a symbol of impermanence. It is proof that even in the silence of space, we are never truly alone. The universe is wide, mysterious, and waiting. PN7 is but the beginning. The frontier is not ahead of us, the frontier is all around us. And as long as we dare to look up, wonder, and reach, humanity will always have a future among the stars. If the journey through the story of 2025 PN7 has inspired you, remember, the cosmos belongs to dreamers. Every like, every share, and every subscription is not just about support for this channel. It's a declaration that curiosity matters, that exploration must continue, and that the stars call to us all. This is famous frontier. Remind you, the universe is vast, the stories are endless, and the adventures has only just begun. Thank you for watching.